Hello and welcome, everybody. Good afternoon, good
Hello.
morning, and good evening. Hi, Michael. Thank you for
Good
joining today.
afternoon.
Good afternoon,
Yeah.
indeed. Looking forward to this session today. So today
Yeah.
we're gonna do a first part of our training series this month. Over the next 4 weeks, we have every week a training session. So this is the kickoff event with an intro to Neo4j. Next week we're gonna talk about Bloom. Week after GraphQL and the week after data science. So every week will be a little bit different. Looking forward to these next 4 weeks. Welcome everybody for joining. Thank you for taking the time and your interest in getting started with Neo4j. So this is the intro session. This is a very will be an overview of what's a graph database, what's Neo4j, how to start, how to get going, and what you can do even with Neo4j, and also some hands-on. So this is a good place for everybody that has no idea or has only a little idea what Neo4j and graph databases are. Before Michael, you dive in, quick info for everybody. So this is obviously broadcast live, and we are recording it. So if you want to watch it later on or share it or whatever else, you will find a recording link. I will send everybody that has registered via our website. I will send it to their inbox. If you're watching this somewhere else, you probably will find it on YouTube afterwards as well. You have to find it for yourself. If you have questions, use the chat function. We will have a look out for those. So chat is open. Chat is obviously welcome. So if you want to know anything, or even just let us know where you're watching this from, type it in
Yeah,
chat.
exactly. Please let us know
Yeah.
where you're watching this from. I'm watching it I'm attending from my childhood room, actually. So where I grew up as a child, because I'm visiting my dad, and so it's a bright sunny day, and I'm in a room where I have lots of fond memories being a child, and
Nice.
so
Yeah.
it's the first, I think, that we've done it from here.
Yeah.
Uh,
That
but
is the first. Yes.
looking really forward to it. And Alex said, please share where you're watching from or attending from, but also please use the opportunity to ask questions. So, of course, I have things prepared, but in general, if you have questions that we can help answer, as long as they are like still in the realm of intro to Neo4j, right? So we won't dive into like deep clustering or other questions in the intro session, because then for the others in the session it's probably not as helpful. But if you have intro questions around graph models, about how to connect to Neo4j or similar things, please feel free to ask, and I'm more than happy to answer them, and so that everyone benefits from those as well. So really looking forward for these 2 hours with all you watching, and with you, Alex,
Yes.
keeping everything going. Cool. And without further ado, I'll share my screen. Please let us also know if you can see and read everything well. So let me just pick the slides here. So as I said, it's an interactive session. Please let us know where you're from, and please ask the questions as we go along. Alex, you can always interrupt me and ask the questions if I'm not seeing the chat. Then please bring them up as they come in. Right. And today we want to look at graphs in general. Why are graphs really cool? Why are they basically a really great representation of the real world? And where can we use graphs? What are scenarios or use cases for using graphs? Looking a little bit at the property graph model, and a quick introduction to Cypher query language. And then what we actually want to do is we want to go heads on, and all of you can code along with us here, because we can use Neo4j AuraDB free, which I think was already shared in the registration notes, that you should have set up an account there. So it should be pretty straightforward and quick to create a database there. And I thought today, also to make it a little bit more fun, we'll have a look at some Stack Overflow data to see what we can do with something where I guess most of you spend quite some time every day. And so we can look at some Stack Overflow data, and then I'll show you where you can continue your graph journey as such. Cool. And before we start with the actual content, let's go over to Aura and log in and create our database so that we can together then have the database ready when we start. So it takes 2 to 3 minutes to start the database. So from that perspective, we can start it now, and then when we come back, it will be there and up and running. So from that perspective, so you can go to neo4j.com/Aura or Aura login, and then you basically click on the button and you log into Neo4j Aura. If you have an account, and then there's this wonderful blue create database button here, which I'll click. And then you have AuraDB free and AuraDB professional, which is kind of the paid offering with different sizes and scales and so on, but we'll pick the free one. We can call our database whatever we like. I call it movies because this is kind of what we're going to use. You can pick a GCP or a region close to you. So I'll pick Belgium because I'm in Europe, but you can pick also Singapore or Iowa for the US. And then today we want to pick the movies dataset because that's our beginner dataset that we want to look at with some Cypher queries. So you click that and then you hit the create database button. And this shows you this credentials dialog here. The important thing is to copy the password because that's something really that you need and you must not lose it. So I'll just copy the password. And because I don't want to put it anywhere else, I just put it into my browser bar here, into this empty tab, and say I have stored these credentials safely for use later. Because I'll remove the database afterwards, you should probably put it somewhere safer than me, but for me it's easiest to just grab it from there again. And then I'll click continue, and then it starts to create this database. So you can click on the database and it says setting up your database. This will take a few minutes. And we come back here after the first part of the presentation, and then we can get going directly with AuraDB free. If you have any questions, Alex can also answer some of them in the chat, or you bring them up and we'll look at them together. But that's where we should all be now if you have already logged into Aura. So just create database, select movies, and give it a name and pick a place close to you. Okay. And while Aura is setting up our database, we can look a little bit at graphs, why they're awesome, and some use cases and the property graph model. Cool. So this is more or less for the people looking at the slides. So create the database, copy the credentials, and then we are ready to use it. Okay, what's a graph? Is it the thing on the left or the thing on the right? We should actually add polls, Alex, to our sessions. That would be fun, perhaps for next time. So actually, what we call a graph is the thing on the left. It's a network of connected entities or connected nodes. On the right side, especially in the US, oftentimes people call this as graph. We prefer to say like diagram or chart to make the distinction. So for us, a graph and a network are what we are talking about via versus diagrams and charts. It's easier in German because then you wouldn't say a graph to the thing on the right side. But there's also graph paper, right? So it's also adds to the confusion as well. Okay, a graph is basically a set of entities or pieces of information that has relationship to others. And graph theory is actually quite old. It started in 1735 with Leonhard Euler in Königsberg in Kaliningrad today, where they had this problem about how can I cross all the bridges of the city without crossing one bridge twice. And he basically took this problem and turned the landmasses into nodes and the bridges into relationships. So it became a graph. And then he said basically you can't have any node with an odd number of relationships in your graph when you want to enter and exit with different exits, right? So because you can enter, exit, but then you can't, you can go over here and then you can go there, but you can't get out here anymore, right? So you have to have always even entry points and exit points to do this. So that was kind of the founding of graph theory. And in the last few years, there's been a lot of use of graphs everywhere, right? So from PageRank and Google to social network analysis, social media analysis, to things like graph neural networks and DeepMind and things like that. So because graphs are really good at capturing context and topology, right? So not just the entity itself, but also what's around it, right? Who are your friends? Where do you live? Where do you work? What are your hobbies? What's your interest? What what news do you follow, right? What are the people that you read, and so on. So basically, it's not just the person itself, but the graph also captures all the context around a person, around the event, around a product or so, and then you get much more insight about that piece of information. And if you squint a little bit, you can see if you draw these kind of arrows and circles on a whiteboard, that's also how you would also specify many domain models. So if you're from a programming background, then if you draw a domain model with, let's say, products and orders and categories and baskets and fulfillment orders and procurement orders and all this stuff, it's all like basically arrows and circles on a whiteboard, and then you turn this into an object model in your application. And depending on what kind of database you use, you either have to then wrangle this object model into your tables in your database, or if you use a graph database, then it's more in one-to-one representation. Okay, what are graphs in general? So actually everything that you can connect is a graph. So I always say there's no such thing as disconnected pieces of information in the world, right? Or disconnected pieces, period, right? So there's people who have connections, historical events which kind of have reasons why they happen, but they also have outcomes. There's things like proteins in biology, for instance, right? There are things like markets, economic markets, especially today. We see that a lot, that like there's so many dependencies on markets. If someone cuts someone else off a market, then they have a lot of problems, right? And not just directly, but also transitively. So not just the organization that's cut off from a market, but also all their dependents. Right. So things like network dependencies in software, for instance. What about my libraries and the libraries and transitive dependencies? And what about security there? Right. So what happens if one of these libraries that I'm not directly depending on, but I'm depending on like 3 steps removed has a security issue? I'm still affected by that because I transitively use this library. So there's lots of things. So here, for instance, water is a very simple molecule, but you of course know proteins and DNA and all kinds of organic molecules are complex networks. And then it's not just about the primary structure, but also a secondary and tertiary structures, for instance, for protein folding that can also be represented as graphs as well. Right? And so transport networks, there's like information networks, there's even like data centers and all the cabling, routers, switches, and so on. So basically the means are endless. Whenever you can basically draw something on a whiteboard with arrows and circles, that can be represented as a graph. So I think graphs are everywhere, and I think that still holds true even 12 years later since I started at Neo4j. Why are they amazing? Because they can represent the data that you have pretty straightforward, right? So this, for instance, is an example of someone or some people buying trainers as a product. And so you can represent the product, but you can also represent the people. You can say what did they do with the trainers? They bought them, right? They didn't kind of sell them or wore them, but they bought them. So that's kind of the bias on the relationship. And then you can also capture when they were bought. You could also capture what was the price that they were bought at, or the location, and things like that. So you can start with a simple model like this one, but then you can evolve it to a more complex model where you then have orders and transactions and like shopping baskets with multiple items and things like that. And then you can say, okay, based on what the people bought, we can recommend them other things that they could buy. For instance, some jogging pants or running outfit that goes with the trainers. Or if they're like more trainers for fashion, then probably the appropriate fashion outfit or whatever. Or like a running course or gym membership or things like that. Right? So that's kind of things that you can do with this. And this is a really simple thing that you can easily draw on a whiteboard. Usually you have 2 options. So either you draw an example on the whiteboard, like you see here, where you really have like Alison, Jane, and Ian as people, and a certain piece of trainers, type of trainers as a concrete example. Or you draw a meta model where you basically have, say, person bought product or person buys product, right? And then that's the meta model. So that's kind of different ways of representing these models. And then because graphs are really flexible, so there's no fixed schema that you have to create upfront to manage a graph. You can add data from other sources, right? So someone posts messages on social media. Other people read these messages on social media. And then basically, if you look at the dates here, then they actually based on reading that message, they actually go off and buy their trainers, and then they post on the next day their own message, right? And then someone else reads this and goes off and buys the other thing. So that's actually social influencing on in a nutshell, if you want to say so, right? So that's kind of how does like a hype product suddenly go viral, right? So there was this really interesting book. The Tipping Point by Malcolm Gladwell. But when does become something viral? And you can represent this as a graph, and then you can also trace why is this product suddenly selling so well. Oh, there's a lot of people talking about it, or special people that have a lot of followers or influence are talking about it. And you can basically follow all these relationships in a graph. And here you already see that we have actually merged two graphs, right? So or actually three. So we have the purchase graph with the people and the purchases, but here's also the social graph, one for Twitter and one for Facebook, for instance, or Meta. And so you can also imagine pulling data from other places in to enrich your graph data, right? So then you could also add logistics and shipping information. Or if you wanted to, if this is really like a sports domain, then you could add information about where are people using these products and connected to Strava and have the running loops of people all around there as well, right? And then you basically can pull in more information. And because in a graph, as soon as you have one connection point, one joint that you can connect things to, you need only one place where you connect a new piece of information to, then you can grow your graph and add more information from other sources to it. So it's pretty powerful, both in its simplicity, but also in its flexibility and extensiveness as well, which I personally still love really a lot. Right, and you can continue to extend this. Okay, one other good example of where graphs have been used quite widely is journalistic investigations. Right? Today we are living in a time where journalists and journalism, especially investigative journalism, is more important than ever because many of the pieces of information that we would like to know are actually hidden away in secrecy or in shell companies or money flows somewhere where we don't want to go. And so, thanks to journalists, this kind of information coming from leaks is captured, analyzed, and they actually do the job that actually banks and governments should do, basically, is trace ownership of companies, trace ownership of ships, planes, and other things, of money, of shares, of influence, right? And so the basic domain model of these investigations from the ICIJ is basically the entity is a shell company. The officer is someone who is kind of responsible for some part of the shell company. Either they're the owner or shareholder, or they're a director or officer, right? So, but what's actually really interesting is the shareholder, which is kind of usually hidden away. The director and officers are usually public, but they are usually employees of a law firm or an offshore entity that they pretend to be directors of this shell company. But oops, sorry. But the actual original shareholders or beneficiary or real owners of these shell companies are not in any public registries. That's why in these data leaks, this information also becomes public, and then you see kind of politicians, celebrities, and other people putting money away and then using shell companies to just trade, right? So instead of me giving you $1 million, I just hand you a shell company that has $1 million worth of equity, and I can do this behind the scenes, and no one knows from whom to whom something like this moves. And then intermediaries are all the banks and law firms that help the rich people basically to hide their money by working with these shell companies and offering these shell companies as such. So that's a pretty simple model, and we can use this for actually drawing a lot of conclusions, right? So because through shell companies, you can connect officers even over 5 or 6 hops. You can say from this one person A to this person B, what's the path that we can go through shell companies that reaches one to the other, for instance, or who has been jointly investing or been shareholder of the same shell company over and over again. So those two people have a lot of connections, so they are more tightly connected as such. So we'll see an example of that in the Stackoverflow data model. Okay, a bunch of good graph use cases and scenarios. There are many more. And also, if you go to neo4j.com/use cases, there are many more listed in detail with with example data sets, white papers, and more detailed customers and so on. So if you want to learn more in detail about these, just go to Neo4j use cases and then you see those. So basically what I want to ask myself, should I use a graph database or should I not use a graph database? Of course, I can represent this kind of connected information also with other databases, like with a relation database and join tables, or with a document database and basically arrays of IDs that point to another document, for instance, right? So, but the question is, this kind of relationship that's kind of treated like a stepchild in many other databases, in a graph database, that's kind of a first-class citizen. So whenever these relationships, this context or this topology of my entities is as important as the entities themselves, and I want to use that to analyze my data, or to work with my data, or to infer more insights from my data, then considering a graph database makes a lot of sense, right? So if those relationships are more than just, an foreign key that I don't really care about as such, but it's really the relationships between entities are important in my domain. And I think personally in most domains, actually, the entities or the connections of entities are way more important than people usually say. Right. And here are some examples, and we look at those in more detail. Something else that's interesting is all kinds of hierarchies. You have hierarchies in product hierarchies. You have sales and purchase hierarchies. You have building, if you want to represent a building or a complex piece of machinery like an airplane. If you go like a BOM model, bill of materials model, then you have like the airplane, and then like all the parts, and the parts consist of parts, they consist of parts, and so on. Or if you look at modern CPUs, for instance, right? So you have like substructures or geography, for instance. But typical things are HR and management hierarchies or sales hierarchies, where you then want to manage referrals or things like that. Or so whenever you have like this kind of hierarchy of things that something is on the root and then goes down, then a graph is a really good fit as well. Another good example is, for instance, source code and abstract syntax trees, where you basically can say, okay, my program or my project is actually the root of the project, and I have classes or files, and then within the files I have methods or fields, and they use other pieces of my program, and then basically it builds up a tree of information. And whenever I have these kind of trees, which are just a special kind of graph, then a graph database makes a lot of sense. Okay, the next one is something that's we use quite often when we are traveling. So everything that's routing related. I don't know how many relationships are between two things, right? So for instance, if I want to go from A to B, what's the shortest path to get there? If I look at something like LinkedIn or other social networks, how far is this one person apart from me? Or as I mentioned before, the software supply chain or library dependency, is this kind of a first level dependency, or is it a sixth level dependency? And one recent thing that I was not so much aware of is kind of the whole supply chain discussion, which is actually much broader than I thought it would be, right? So there's something like managing risk in supply chain, kind of how risky are my supplier and the suppliers, or how much CO2 and greenhouse gases are emitted by not my first degree, but second degree, third degree, fourth degree, and supply chain as well, right? And things like that. And then sustainability is another supply chain example. So that's another one where you have like these transitive relationships, and you can basically go from A to B to C to E. And graphs are really good at kind of following these long chains of relationships as well. And again, routing. So this is basically a British road network or train network, basically, where you basically can say, can I do multimodal transport, like between car, bike, public transport, and so on, and walking? Can I get from A to B? What's the shortest? What's the best? What's the most scenic route? And helping me to find that. So first representing all of that as a complex knowledge graph, more or less, but then also helping people find these routes and being more dynamic and having more information on the relationships that tell you, okay, is this like an easy route? Is this kind of accessible for people with disabilities? Is this something there where I have a good view, or is this something that's through a really bad part of town where it's always kind of I'm stuck in rush hour or something like that. And then graphs can help you to represent this in the first place, but then second also to create a routing information on top of that, right? So and that's everything from personal travel to logistics to ships to shipping fleets and other things as well. Right. So these were some examples. As I said, there are many more. There's also stuff like cybersecurity, network management, IAM, identity and access management, and so on. So like the possibilities are almost endless. Which is also one of the challenges for a graph is you can do so many things. So it's really hard to pinpoint down only this is like the killer use case because there are so many things that you can do with it, right? So there are also some things, if the question comes up, that are not so great for a graph database from in the first place. So think like data warehouse, just number crunching on a lot of data. That's not what a graph database is built for. Or if I want to ingest like massive volumes of event streams, that's also not what a graph database is built for. A graph database could represent, for instance, the network of IoT devices and like a derived model of how much information flows from A to B to C to D E. But like the pure event stream time series database is not something that you would use a graph database for. And then another aspect that graphs are not made for is just blob storage, right? So storing videos or images or large volumes of text in a graph database, that's also not what you would do, but you would store this in either in another database or into some blob storage like S3 or Google buckets, cloud buckets, or Azure blob storage as such, and then just store the URL to the actual blob in your graph, right? Because then you can also use CDN and edge compute and distribution networks for all of this, which makes it much easier anyway. Yeah. Okay, so what does the property graph model actually look like? So I already mentioned it a number of times. What you have is kind of these entities or elements that we call node. In math and science, it's often also called a vertex, but we felt that vertex is not very a friendly term and people are scared away, so we kind of call it node, which is more obvious what it means. And between nodes, there are relationships. In Neo4j, in particular, relationships are directed, but you can ignore the direction if you want to. And relationships always have a type, right? So because otherwise there would be just anonymous relationships, and we always want to have a type for a relationship, right? And really kind of the most important rule in a graph database is there are no broken links. So there are no 404s in a graph database. There's always, if you have a relationship, then there's always a node on either side of the relationship, right? Or you don't have a node that points somewhere, but the end is not there anymore. So that's kind of a rule of graph databases that's kind of a core consistency attribute of a graph database. There are no broken links. There's always something that a relationship points to. And so that means I can't delete a node unless I also delete its relationships. So as long as a node still has a relationship, I can't delete it as such. And what we can add to this is additional metadata. So for instance, for nodes, we can add types or labels. So we call them labels. And this could be something like a type, but it could also represent a role. So for instance, a person is not just a person, it's probably also an employee, or it's probably also an artist, for instance, or it's probably also an spouse or an mother or father. So we can add multiple roles with these labels. So, or like, email tags or tags, hashtags in social media. We can basically add additional pieces of information to these nodes that represent them like being part of a group in a way, right? And so that's, for instance, in our case, where we had here Jane owning her bike. This is basically a person owning a bike, right? So that's kind of type bike, and type person as such. And you can have more than one. Then you can also say, okay, that's not just a bike, it's a vehicle. And then there are other types of vehicles as well that a person can own, right? And then on both on nodes and relationships, you can add arbitrary properties. So properties are just key value pairs. And you don't need to declare them upfront. You can add as many or as few properties as you want. And so you don't need to prepare a schema or something like that. So there might be some users where you only know the name or login, and some other users that fully filled out their profile. You have all the information here as well, right? So and that's something that's quite nice about a graph database, that these kind of attributes are also, or properties are also dynamic. So you just store the ones that you have, and you just leave off all the ones that you don't have. For relationships so for properties on relationships, oftentimes they qualify the relationship. So there's, for instance, something like a cost or a distance or a time frame or things like that. Or is it active or not active? That's what you would put on a relationship property. But of course, you can also put other things there, right? But that's common usage of relationships on properties on relationships as such. Right? Okay, and how would I query this graph database? Of course, there are slides, but I actually want to do this with you together. So I just do the first few slides, and then we go into the real graph as such. So we query Neo4j and many other graph databases with Cypher, which is a pattern-based query language. So initially we looked at SQL, we looked at other query languages, we looked at Sparkle and others, but we didn't feel that any of those is really well suited for graphs. Either it's too verbose or too cumbersome or too unwieldy. We wanted to have something that's really humane, that's easy to read, easy to understand, can represent graphs really well. And so we built our own query language initially for Neo4j, but then open sourced it to everyone. And so now with OpenCypher, everyone can use Cypher as a query language as well. And many graph databases already do as well. So it's a declarative query language like SQL. It's very expressive. I think it's pretty darn good in kind of representing complex queries with a few lines of Cypher. It supports pattern matching, which is kind of everything is around pattern matching in Cypher, and you'll see in a second what I mean with pattern matching. And it has ASCII art. What else would you wish for? If you want to have a quick reference guide for Cypher, just go to dev.neo4j.com/refcard. And this gives you the Cypher ref card, the current one, right? So if I go back here and say dev.neo4j.com ref card, then it takes me to the current Cypher ref card. And then I can look at all the things that I want to look up. So that's a quick reference for that. Okay, and with that, I actually want to leave the slides and go into our database. So as you remember, we have our movies database running. I hope for all of you, your movie database also is now green and running. And what we can do is we can click on this Open With button and pick Neo4j Browser as our interaction tool, because that's like an interactive query UI that allows us to query the data. And so we have our database connection URL already filled in. Username is Neo4j, and the password is what I just pasted here into my browser tab. And you hopefully stored it safely somewhere, right? So now I have my connection to my database. And because we started with the movies dataset, this database is already filled with some example data, not a lot, but it's a small, cute, little tiny data set. So we have movies, people, and a bunch of relationships here. And it's 171 nodes and 253 relationships. So it's really just an example data set. We can start by clicking on one of these. So for instance, we can click on people and say, okay, what do we have here? We have 25 people. It says limit 25. So we have 25 people. Here on the right side, we have the legend for our nodes as such. So if you hover over a node or click on a node, then you see the attributes of a node here. You can also fold this in and fold this out, or make it bigger or smaller, depending on what you want to do. And then if I have these people here, I can on one side I can just chasing nodes all the 2 hours today. That's kind of one thing that I can do. But I can also click on this and say expand relationships, which is this little icon down here. Or I can double click also on it. And if I do this, then I see Keanu Reeves acted in all these movies, right? And then I can pick one of those movies, like like the matrix, for instance. Click on that and expand it from here, and then I see suddenly other actors, right? Hugo Weaving, Carrie Ann Moss, and Emil, which is actually a fake. So it's kind of for us to get rid of Emil later on. And then we have directors, so people that have a directed relationship to Matrix, Lily and Lana Wachowski, and producers as well. All right. So this is kind of our basic data set that we can either explore interactively, like I did here. So I can, for instance, say, okay, what else did, for instance, Lana Wachowski in our data set at least write or direct or produce, right? So I can just expand the relationships here and then continue from there. So you can also see that I already interactively can follow my things like I would draw them on a whiteboard for these kind of small example data sets. Okay, but let's go back to our query language because that's what we wanted to talk about. And as I mentioned in the beginning, Cypher is a pattern-based query language. So if you, by the way, if you want to go to multi-line mode, you can just press Shift and Enter or Shift and Return, and it goes into multi-line mode. So it starts out in single-line mode, which is this one. But if I press Shift and Enter, then this gives me here the multi-line mode. By the way, just quickly, there's more stuff here on the sidebar. So we saw already here the overview of the database, also property keys. I can see more information here. I can store favorites here. So for instance, if I have a query that I really like, then I just click on this favorite button here, save as favorite, and then it adds it here, and then I can pick it up from here again and run it and so on. There are guides, so we can also look at this interactively. So if you get lost or if you don't want to type stuff, then you can also go to the guides and click on any of these queries, and it puts them into the input field over here, and then you can use them from here. There are also more guides available. And then there's help, links to important commands, like help keys is quite important, and then other commands as well, which are quite useful. Like history is an important command, because if you want to look at what you've typed so far and want to save this, for instance, then you can do this. Or what you can also do is show the schema. So for instance, if I click here, run, then I see I have my schema is between person and movie, and a person can follow a person, and a person can act it in, review a movie, produce a movie, write a movie, or direct a movie as well. So I can see actually visualization of my graph schema, of the data in my graph. And a bunch of other things, and then links to docs and to developer guides and Graph Academy and many other things as well. Settings, most of them we don't need to touch today. And there's only one that's, I think it should be checked for you. It's called Connect Result Nodes, which is useful for beginners when we start out with Graph Database. Later on, you might want to disable this because that fetches additional connections between nodes that you return. So if I return a bunch of nodes, the browser actually goes and fetches additionally what connections exist between these nodes to have a nice graph visualized. But if I already know what I want to return, then this connect result nodes is not so helpful. And then a bunch of license links over here. Okay, but what I want to do is we want to interactively look at Cypher. And for that, I just picked my query that I took from click on person here, and go with this as a starting point. And then we go from here. So I'll turn this into a full screen frame here. So the frame is full screen. And then I can zoom in and out. That's actually a new feature that actually just made it. So zooming in and out with just my mouse wheel is something that I've been waiting for a long time. So that's really great. And the new feature is also fit to zoom, which kind of fits my whole graph into the visualization. That's also nice. Okay. But what we want to do is kind of look at some of the Cypher aspects that we can do here. So I just moved this into a multi-line thing, so it's easier to edit and move stuff around. So first thing that I wanted to show you is kind of these patterns here, right? So I have returned the people, and then I expanded them. But what I can also do is I can say, okay, give me all the nodes, right? Give me just 25 random nodes. So I just remove this colon person. And then if I do this, then it returns both people and movies. at the same time. And then you see the connect result nodes actually goes off and creates all these connections between my people. So even by just fetching a bunch of nodes, I get already a visualization of the graph as such. If I don't add a limit, the browser gets a little bit slower because it needs to basically in JavaScript manage all this graph visualization. I think there was a recent update to the graph visualization library, so it's a little bit better today, even with a larger data sets. So for instance, this is like almost the whole movie database on one screen. And we see kind of clustering around nodes, like the actors and directors clustering around nodes. There are some nodes that have joint repeated actors and directors, like here is the Matrix trilogy, so we don't have like the current movie in here, and so on, right? So there's this kind of stuff. So with limit, I just say how much data is returned from my query, and I just put it back to 25. And this is basically showing me a number of nodes and relationships. This n here is a variable, right? So I can call this whatever. I can call it foo or bar or m for movie or n for node, whatever I want to call it. I can also spell it out. For instance, if I say I want to just see movies, then I say movie and then colon movie is the label, and I just want to return movies, and so it returns 25 movies for me. Yeah. And so whatever I call this is not important. It's just for me. And I use this to later reference this element that I found in my pattern as well. All right. So one thing that we can do with our elements is I already mentioned that we can look at the attributes here in the sidebar, but we can also look at the table view of our result, which then shows us the properties. So each movie has a tagline, a title, and a release year. And we can also have a nice ASCII table of this. So if you want to copy the results somewhere, then you can basically copy this ASCII table quickly as well. Okay. The other thing, if we return like nodes and relationships from our graph, then we see the graph visualization here immediately. But of course, we can also return individual properties only. So for instance, we know that movies have titles and a year. So I can just say return movie.title and oh, it's released, right? Oh, there's actually, of course, how could I forget? There's actually full Visual Studio Monaco code editing support. So you get also like highlighting and other things, and code completion as well. So movie here, movie with command space or control space. If you press F1, you get even like typical VS Code commands as well, which is quite nice. So if you want to capitalize something also, right? So for instance, if this return was lowercase and I wanted to make it uppercase, and I press F1 and then uppercase, transform to uppercase, and then my return is beautifully like this. Okay, and if I return this, actually, movie title and movie released, then I get a table back with just these attributes. Right, so I can do this both for nodes and for relationships. If I just want to return attributes, then I can do this. And please come along with me and type these things and do it yourself, so you get a feeling for the language. And don't just watch me doing stuff. I actually urge you to do it yourself. Okay, so we had our movies here that we had returned in our graph visualization. And what I did before about like this manual expanding from movies to actors, we can actually also do in our query language as well. So for instance, if I want to say I have a person which has some kind of relationship to our movie. So I press just basically the movie and the person. And if I had connect result nodes, actually let me disable connect result nodes so it's a little bit more obvious. So I just go to settings here, I disable this. So if I find the movie and the person as such and return them, let me call this person, then I basically just get independent pairs of nodes, right? So I get a bunch of, let me make this full screen again. I get a bunch of people and a bunch of movies, and then it limits them to 25 as such. So we have only one person actually here. But what we actually want to do is we don't want to just see the movies and the people, but we want to have the people that had some role in the movie, right? So, and what we do is basically we just add an arrow here. So if you squint a little bit, you can see that these round parentheses around nodes are actually like the circles on the whiteboard, right? So we can just complete the circles and then we have our little circles on the whiteboard or here in our graph visualization. And you could imagine that these are like the round parentheses here. And similar for relationships, we just add two dashes and then greater than sign, and then we have an arrow. So this even has font linkages that you can also enable and disable, I think. And so we can say people and their relationships to a movie. But right now, if I just run this, then the relationship will not be returned. I still will get the people on the movies because I here a variable.
Michael, you are
Right.
sometimes
Yep.
touching your microphone and then makes a awful scratching noise.
Oh, sorry. Let me just see because it should actually use my AirPods and
Yeah,
not my
I
microphone. Input. Okay.
don't know.
Okay. Is it still scratchy or perhaps
No,
it's
it's
in Restream? Let me just see in Restream if I have. Sorry for that. In the settings. That's explicitly.
okay.
Okay, so I hope this is better now.
Should
Okay,
be.
and if you return R now as well, then we actually get person node, movie node, and the relationship between them returned, and 25 of those. Right. So if I do this, then we see, oh, suddenly we have an a person and a movie, another person and the same movie, and the third person and the same movie as well, right? So, and because I didn't specify any type for the relationship, it returns acted and directed relationships as well, right? And the same on the other side here. So it just is visualized as a graph because it can pull it all together and deduplicate the results. But if I look at the table view, actually I get one row for each movie person relationship, right? So that's kind of what it actually returns, but then the visualization pulls it together into the graph visualization here. And if I were to restrict the type, so for instance, if I were to say I only want to have people that have acted in the movie, then I should only get actors. So this directed relationship here should go away, this one should go away, and so on. So let me run this. And now I only have acted in relationships here as such. Right? And now I can also say, if I want now to access attributes, I don't want to see the graph result of this, then I can say movie title, person dot name, and r dot roles, because on the active in relationship, there's a roles property of the roles that the person played in this movie. And if I run this, then I see movie title, person, and roles. And Emil is still there as a fake, but we'll get rid of him at some point. And then the other people with their roles as well. And some people played many roles in movies. That's why this is an array. Could also represent it with multiple acted in relationship that have just one role. It's just a modeling decision that was made in this data set here. Okay, so that's that. The other thing that we can do here is if I just go back one level. So you can, by the way, with command or control, arrow up and down, you can go through history and then see previous things that you've run as well. By the way, if you call help keys, as I said, showed you before, you see also the different keys that you can use in the editor, but also in the browser itself. Okay, and with command up, I get back to my Sasso query. So if I run this, it gives me like the first degree network of a person, right? So the person who acted in the movie, and that's it, right? But what happens if I want to go from this movie further on, right? So who else acted in this movie? So other people that acted in this movie, and then perhaps even the movies that they acted in, the other movies that they acted in. So 3, I just give it all R2, R3, and acted in. So this is now a complex pattern, right? But I can still imagine drawing this on a whiteboard, like a person who acted in a movie, and then other people that also acted in this movie, and then those people acted in other movies as well, right? And then because I don't want to spell out all the stuff, I can just say return star, and then it returns basically every named element here. If I don't name one element, then it's not returned, but I actually want to more. So return star gives us the 1, 2, 3, 4 hops out relationship from our starting point. Right? So if I do this, I see that from one person, actually I'm not sure who was the starting person. Probably Keanu Reeves. It looks like it. From Keanu Reeves to Matrix, from Matrix to the actors that acted in Matrix, and then from here to another movie, and then to another actor, and then to another movie. Right. So B for Vendetta and Cloud Atlas are actually our end points here, and probably also the 2 other Matrix movies as well. So that's like the third-degree network of someone that can spell out in really a single line of cipher. If I had to write this in SQL, this would be 1, 2, 3, 4, 5, 6 joins. And then I wouldn't actually see my query not anymore for all the join clauses as such. I can also, because I now kind of try to figure out who's the starting point, I can also look at, of course, the table representation, and I would see that my start person would be Emil once, and then Keanu Reeves or something like that, Lawrence Fishburne. But I can also say what I want to be the start person. So there are 2 options. First option is I just put in curly braces here and say name Keanu Reeves. So with an JSON-like syntax where I put curly braces and then key value, and then I just for Keanu Reeves get these results. So we have Keanu Reeves here, and then we see the first degree to his movies, and then second degree is the actors that acted in those movies, and third degree would be the movies that those actors acted in. Right? But you can also say we want to start it with someone else. We want to say, for instance, Tom Hanks as another starting point, and then we see the third degree network. Tom Hanks is in the middle, and we see all of this around it. The other option in Cypher that we can use is not the curly brace syntax, which is just syntactic sugar for actually a where clause. So where clauses are very similar to other query languages. So I just say where person.name equals Tom Hanks. And this is basically equivalent to what I had before here in my query, because that's internally just rewritten by the query parser to this format. Right? So then it basically returns the same as such. Exactly, and for these where predicates, I can do all kinds of stuff, right? So I can also say end movie dot here is movie dot released is greater than 1990 or something like that, right? So then probably some movies are all, let's say 2000. And then some movies are gone, and then my graph is much, much smaller because this database doesn't have so many movies in here. Right? So I can do the regular predicates and then or and then so on. And Neo4j also has support for spatial types and for datetime as well. So from that perspective, I can also do more complex things as well from that perspective. Also like GIS point distances and bounding boxes and all these other things as well. So that was that. Another really cool feature that exists here I mean, it's a feature that exists in all query languages. Let me just simplify this a little bit here, which is aggregation, right? So if I return person name here and count star, then it basically says, give me for each person the number of movies that they acted in, right? So as movies. So I see Tom Hanks acted in 12 movies. So if I comment out this where clause, so by the way, comments are 2 slashes or an slash star, like in many programming languages in Cypher. Then it would return this for every actor, the name and the number of movies. What's really nice, we don't need a group by. So I always hated group by. That's why group by didn't make it into Cypher, because you only have to provide the grouping key, and then every aggregated field is so as soon as you add one aggregation function, then all non-aggregated fields are automatically the grouping keys. So that's the proper statement here, right? So you don't need group by or stuff like this, which is really nice. That's also a really powerful aggregation function called collect, and which creates a list of stuff. And I can say collect movie.title, then as titles, then I get all the titles for the movies that someone acted in, right? So you see here are the people and their titles. Right? If I now want to say, okay, I want to sort this by order by movies descending, then I can do just add this after the return, and then it gives me the top 25 people. So Tom Hanks leads this with 12, and then Keanu Reeves, Jack Nicholson, and so on. If I wanted to, I can also do more complex operations. So for instance, instead of collecting just the titles of the movie, I can also say, okay, actually, I want to have the title and the year, for instance, of a movie here. So I can just create a map of title is movie title, and year is movie dot, released. Movie dot released as movie details. And then I get a list of objects or dictionary or hashes, whatever you call them, maps back here. And of course, the syntax is a little bit tedious. So there's a shorthand syntax, and we can just say stolen from GraphQL. Basically, we just say m and then dot title dot released, and this will return the same movie. Will return the same thing. Right? So I can combine these kind of things really nicely. Okay, I have one more thing without going into way more detail. So this only really scratches the surface of Cypher, and there's way more that you can do. Actually, I have 2 more things. One is Cypher is composable. So each of these query parts here can be composed together by taking this return and just turning it into a with clause. And let me just change person to just to a person node here. I can basically do in-query aggregation and in-query filtering and in-query ordering and sorting and limiting and so on. So for instance, if I want to get the top 3 people by movie count, right? I want to get the top 3 people by movie count. Then I do this with. So I have an in-between in the query aggregation and ordering and limiting. And then I can continue to do stuff with those people and all the other data, right? So now I can say, okay, and of those 3 people, I want to see if they also directed movies as well, right? So I can say, okay, I just get the top 3 plus the movie information where they acted in. But then I want to see, okay, who of these top 3 also kind of directed movies? So I just add this. So this is almost like query part 1 and query part 2. Query part 2, right? And query part 1. And I can chain as many of those together as I want, which also means that like all the stuff that you usually would do with having or so, you can actually do in the query part 2 as well, right? So you can have, there's no having in Cypher. It's basically just chaining query parts together. And then we can just return person.name, for instance, collect directed dot title as directed movies, and then we also return movies and
movie details as well, right? So I can do arbitrary other stuff that I want to do in the next query part and so on until at the end I can return things as well. There are also subqueries, which are more recent addition to the language. They then can nest things as well. It's also possible. So we now see Tom Hanks has one directed movie, here 12 acted in movies, and then all the movie details. And I think he might be the only one of the top 3 people in our dataset that actually had also directed movies as well. So this match is actually exclusive. So if this match doesn't find anything, that's kind of basically produces 0 rows, and then that person will not return results, right? If I turn this into an optional match, then it's like an outer join, basically. And then if this doesn't produce anything, then directed will be null, and this relationship will be null, and then this is kind of an empty list after all. So that means if I run this now with this optional match in part 2, then I get all my actors, but they have no directed movies here because it's just an empty list then. Right? And count would be 0. If I do count on directed, then this would be 0 as well. Okay. Oh, there's one thing that I forgot that I also need to show.
Maybe we should we do a little break here and go into a few questions, or do you wanna?
Yeah, happy to take questions.
Okay.
So I don't know. Do you want to read them out or?
Yeah, I can read them out. I was thinking we are at halfway point here, and I think it's maybe a good idea to do some. I think the first question that I wanted to ask you was just answered. I guess Lavanya asks if the keyword the search for nodes also can work on relationships. So if you want to count the acted in relationships instead of the movie nodes, that would also work. I guess you kind of showed that already now.
Yeah. So for instance, if I do count R here, then as acted in count, then it would kind of count basically the number of relationships that kind of come by, which means it's almost the same number as movies, because for each movie there's also one acted in relationship. But if I want to have distinct counts, then I could say count distinct R or count distinct movie. Then it only counts non-duplicates, basically, right? So that's kind of an option if I don't want to count the rows that come by, which count Stardust, but if I really want to count distinct elements, then I would do it like this with a distinct modifier inside of the aggregation function.
Okay. Then another question from Niharika: can we save cipher code to a file? Is there a way to export cipher queries?
Yes. So if I go here and if I turn this into a favorite as well, like I call this. So by the way, you can name favorites. My favorite query. Then you can. Oops, didn't pick my favorite query here. So it's this one, and then you can say I want to edit this, rerun this, and so on. And you can also save them as well. So if you click on this download button here, export, then you can save them as well. Or if you want to save your full list of clear this, your full list of commands that you added so far or ran so far, you just enter :history, which gives you the history of everything that you've done so far for our session here. You see there's a lot of stuff. Yeah. And then here in the history, you have this export history, which then creates a file, and then you basically have all the queries in there that you can then use in a script or in a shell script or in your program as well.
Perfect. Cool. Then I had one question from Fabio, specifically on the case where you were just are at the moment. Is there any advantage, performance, how the query is processed, etc.? The specifying in this case the person name inside the match clause versus the where clause.
No, there's no difference between the two. It's really just a rewrite, right? So it's basically behind the scenes. If the two queries arrive at the query planner, they're looking exactly the same, because it basically what it does, it takes whatever is in the curly brace here and rewrites it exactly into this where clause. So that's basically what the database sees is basically the query of the where, which is then further optimized. So there's no difference between the two.
Okay. And then maybe taking one more from Gideon. If you put a limit, like you put here limit 3, what is there a reasonage how these the results are shown, or are they completely random?
So because I order them here, they're not completely random, right? But if you don't provide an order, then it's not defined, right? So there will be some consistency of how things are getting returned between in the same database and in the same session, but there's no guarantee that it's always the same order, right? So because depending on what you put in here in terms of like predicates and other things, the database or the query planner will rewrite your query as well. So sometimes it kind of starts on the movie side, sometimes it would start on a person side, and then there might be different orders. So if you don't order it explicitly, then the order is not guaranteed to be in any particular order. So you can't rely on it as such.
Okay, makes sense. And maybe taking one more question, because I think it's maybe interesting. Is there, for new people and beginners, is there a tool to translate traditional SQL to Cypher if you are very much as SQL pro but don't know how to start?
Yeah, we've been thinking about this. So there are some tools that do it under the hood, but there's nothing that I can remember that does it explicitly. But it would be actually quite a nice tool for learners to do it. The challenge is probably that you have to provide also the graph model to your translator, and then the Cypher queries that come from your SQL are probably not very optimal as such, right? So you could do something like, actually, we have a developer page. Let me show you a developer page that's called RDB to Graph. And this shows you basically what are the differences between relation databases and graph databases. And there's also one that's called from SQL to Cypher, comparing SQL with Cypher, where we actually put in side-by-side comparisons based on the Northwind dataset, where we say, what is the SQL, what is the equivalent Cypher, what is the SQL, what's the equivalent Cypher, and so on. So that's kind of something where we basically taught it more explicitly how you would take a SQL query and turn it into a Cypher query. But I don't know any public tool that does it. I know that there are tools like the BI connector that does it under the hood. Because tools like Tableau generate SQL, and if you want to connect something like Tableau to Neo4j, then you need to convert that SQL into Cypher as such, right? So Power BI, Tableau, Looker, and so on. So this tool, the Neo4j BI connector, does it under the hood internally, but not explicitly, not publicly, as in like side by side to text areas or something like that. That doesn't do it as such, right? So here you say it translates SQL into Cypher, and but it needs to know the model as well to do it efficiently. And then, of course, it will never be as good as an handwritten query that you know what you're doing there. Yep. But really good question. That's actually a really good point. That would be quite useful for someone, at least for learning. You shouldn't rely on something like this for production code, but for learning, it would be nice to kind of switch back and forth between Cypher and SQL and see what it would look like as such.
Yep. Okay.
Cool. Super. Good question. Thank you.
Yep.
If there are more, feel free to interrupt me and let me know.
Yeah, let's continue for a little bit, and then I gather a few more questions, and then we can take them on.
I want to spend a few seconds on one particular graph feature, which is when we looked before at these. Where's my history? Now I removed my history. Here. When we looked before at the longer path this one here, right? So we had person acted in movie, acted in another person acted in this movie, and then we had that person acting in other movies. So we can probably call this other person. Or we can say other colon person, and we know also that's a movie. And then we call this M2 and movie, and then we are good. So, right? So this is basically a more complex pattern. And if I don't want to return star, and then if I don't want to name R and R1 and R2, but I actually want to have something that's more readable from a human perspective. So I care more about this path from person all the way to the second movie. Then I can actually call this a path here and assign the pattern to a path. And then I return my path. And then it's basically the same as I had before, but there's a real graph construct here, right? So you see a path has a start point, it has an identity, a path has a certain length, so I can also return the length of or the size of a path. Oh, sorry, length of a path. As well, so you see that this is the path length 3, so it counts the number of relationships in the path, 1, 2, 3. And I can do things with this path. So for instance, I can take all the nodes of this path and do something with them. So for instance, I can say, give me for every node in this path, I want to get the labels of the node, for instance, right? So I can use these paths also for further processing as well, right? So so you see here I get person movie as my path labels as such, right? So this path is pretty powerful as a concept as well. And it's this really this path through the graph as such, right? Which kind of goes from the starting point all the way with all relationships in all other nodes. And it's one, as if you would take a highlighter and on top of the graph visualization, you would draw a line with a direction, then that's the path. So, right? And these paths are also interesting in another way, which is finding shortest path. So that's more like a graph operation where I say, I have a starting point by Tom Hanks. So you probably heard of 6 Degrees of Kevin Bacon, right? If you haven't, it's basically like the Erdos number is how far am I from that one person, right? So, and if you want to do this, we can actually put in Kevin Bacon here. And so we would get like our Kevin Bacon path here, right? So we have Kevin Bacon here somewhere and then get 3 hops away from Kevin Bacon. And so we can now compute actually how far are people from Kevin Bacon, because one can compute the shortest path. And to do this, there's one thing in between that I need to explain, which is so here I spelled out explicitly 1 hop, 2 hops, 3 hops. But I can also do this in a shorter syntax by saying, actually, I'm just caring about the active in relationship between person and movie, and I've just put in a star here. That means so many hops, basically. And then the 3 that says 3 hops, right? So that's basically the same as we had before. And if I run this again, I get the same results as well. Right? But I can also say I want to have 5 hops here, right? So then suddenly I have person, movie, and its length 5, right? So that's a really easy way of not having to spell out each individual segment of the path, but just say 5. Or I can say 2 to 5, right? So then I have 2 to 5. So if some that have length 3, length 4, or I can say at least 2, or at least 3, right? And then going upwards. And there's a path with length 75 that's returned, right? So if I don't add an upper limit as such, because it goes like in circles, right? So I mean, it goes from A to B to C, except it doesn't follow the same relationship twice. So if it finds another way to go to the same node again, that's what it does, but it doesn't follow the same relationship twice. So if there are just a few relationships, like if you remember the Königsberg bridges, then it wouldn't get that far, right? And then it can also say 3 to 10 and get it. So that's a really important thing. That's variable length patterns and paths. The star and then from to as such, which is also something that gets us to our Bacon path. So we want to go from person to person, right? person 1 and person 2, where person 1 is Kevin Bacon, and person 2.name equals someone else, like let's say Mac Ryan. Right. So if I just run this like this, then it will take a while because it will go off and try to start at Kevin Bacon and then go over the whole graph and try to find somewhere where in path ends in Mac Ryan. But what we actually want to do is we want to say, give me the shortest path between the two. So I just wrap a shortest path expression around our pattern. And then we should be getting back the shortest path between Kevin Bacon and Mac Ryan. So let's try this. And this is a path of length 4. So because we have person movie in between, right? Because there's always a movie in between. It's not just person to person to person to person. There's always a movie in between. That's why it's length 4. And actually it would be half of that length. So it's actually length 2 as distance. So I can provide, of course, aliases here as distance. Right? So, and now we can say, okay, this is nice. And I can also see it in my graph visualization. Here's Kevin Bacon, and then via Tom Hanks we can get to Mac Ryan. So we can also say all shortest paths, all shortest, and then it would give me on one side I have Mac Ryan, on the other side I have Kevin Bacon, and then I would all the paths of length 4. So some of them are going via Tom Cruise, and others go via Tom Hanks over here. Right? But these are all the shortest paths in this data set here, of course. And then I can also find out, for instance, if I wanted to pick someone else like Clint Eastwood, then I know that I would see that this is distance 4. So that's actually much further away from Kevin Bacon in this data set. Right? So you see there's Robin Williams somewhere in here. Let's just pick one shortest path. Shortest. So here is Kevin Bacon on one side and Clint Eastwood on the other. And then via action in relationships, it's actually quite Birdcage. We just recently watched Birdcage Family, which is a really nice movie. So you see here really the path split out. Right? And now what you can also do is kind of to say, okay, I don't actually want to limit it to Clint Eastwood, but I want to find the shortest path to Kevin Bacon in my dataset, order by distance ascending this time, right? Not descending, but ascending. And then let's say limit 3 or something like that, right? So, and person 1 is not equal person 2, because otherwise you would also find Kevin Bacon and try to do shortest path to Kevin Bacon, stuff like that. Okay, and so we see actually all the level 1 shortest paths, right? So because it's all the people that kind of acted in with Kevin Bacon in the same movie. Right? So it's basically that's the people that are closest to this person. And so you can imagine that's something also that I can use in a social network when I follow someone who's kind of, how far am I from that one famous person, for instance, and through my contacts or on LinkedIn and so on. So it's, and then as you can see, if I remove all this extra stuff here, then you see that it's actually just expressing the path, putting in the starting point, and that's it. And this is already my query that I need for my LinkedIn. How far am I from this person, basically, thing, which I find always pretty cool to do. And just a quick hint, in my program, I would not put in the literal value, but I would just say $name as a parameter. And then it can give me parameters here. So this is like in so I can say here, for instance, Tom Hanks, params. And now it works with parameters. So that's what I would use in my program code, is basically passing in parameters and then running this query with the parameters, and if I change the parameter, then it would return something different. So if I change parameter to, let's say, who else is there? Lawrence Fishburne. I hope I didn't misspell his name. I probably misspelled the name. OU? Let's see. No. Okay, doesn't matter. But so I can basically in my program code then use this to connect to database and run these. Speaking of program code, just looking at the time, how much time we have left. If you go to the developer guides, as we were before, there's here for developers, drivers and language guides. And you can connect with all these different languages to Neo4j. And for instance, if you pick JavaScript, then you can see here an example installing Neo4j driver, and then you basically see require Neo4j driver, connect to the database with the connection details, and then run the query. And here you see the parameter thing again. That's what I actually want to show you, is that I pass any parameters like in a parameterized query. So this is not string interpolation, but this is really proper query parameters, so you don't get injection dangers and things like that. And also optimize, because the database engine can now optimize the statement, and no matter what parameter you pass in, it will be using the query blended and optimized ones. Right. But this is also available in Aura. I just remember that. If you go to the sidebar in Aura, you also see, let's say this time we pick Python. And if I had not chosen this really small resolution, then you would see this better, but it basically says pip install Neo4j, and then here's the code for connecting with Python, creating data and querying data as well. And you see again here parameters used. So cool. And actually for my database, I can pass in my URL, and then it would use the driver URI as parameter here as well. So if you want to look for these connect examples, then you find them in Aura, but also on the developer pages as well. And if you want to learn more about this, there are actually really, really cool courses that we just recently launched. One is called Building Applications with Node.js in Graph Academy, and the other one for Python. We're currently working on the Java and Go versions of that. And if you go there, then, oh no, this was already the right course, sorry. Then you can basically start Graph Academy and build an IMDb type app with a pretty cool UI. So my colleague Adam did a really great job of creating a really nice looking UI as well. And with the backend either being in JavaScript or Python or Java or Go or .NET, hopefully soon as well. So if you want to learn this and also learn about drivers and sessions and transactions and whatever you need, then you can go there to Graph Academy and take one of these courses. So with including project setup, drivers, authentication strings, and then basically building endpoints for the different operations, right? So you have the endpoint, and then how is it implemented, and code examples, and GitHub repositories for these as well. So it's really, really well done. Speaking of Graph Academy, there will be another teaser at the end, but in Graph Academy, there are lots of really cool courses. So there's the dev courses, there's a data import course, which is really great, Ceph fundamentals course, which goes over the things that we're talking about, and modeling course is there as well, Neo4j fundamentals, and an intermediate Cypher course is coming soon. So this is kind of our new Graph Academy, which is much more interactive and fun and quick to cover. And so if you're interested in learning more by yourself, then check out Graph Academy for that. Okay, I think I covered all the things that I wanted to cover in the in the query bits. So you still, we'll send you the link to the slides as well afterwards. And then you can see for yourself what we've done. So this is all the, oh, creating data. Yeah, let's do the create data aspect as well, creating and deleting data. So I'll do a few minutes on creating data, and then we look at Stack Overflow as well. So let's start with deleting data, right? So as you remember, there's this kind of weird email person, our CEO kind of sneaked into the dataset where p.name equals Emil Efron, return p. So this is this Emil node, right? So who acted in the matrix, but he doesn't really belong here, so we want to get rid of him, right? So this kind of our first task is kind of how can we get rid of Emil. So we could say we could try delete Emil, but this would fail because Emil still has relationships, right? So the relationship to the matrix. So either we now go off and say, okay, find also the relationships and delete the relationships and then delete the node. It's one thing that we could do. The other thing is there's a command that's called detach delete, so which deletes a node and its relationships. So if you run this, then Emil is gone, and so if I try to find Emil again, he's no longer there. Right? So that's how to get rid of data, but also we want to see how to create data actually. And so imagine, so this data set has people who have also reviewed movies, right? So there's Jessica and James who have reviewed movies, and Angela. And I also want to review a movie, right? So you can pick your own favorite movie that you want to review. So first of all, I want to create a node for myself. So I just use this. So there are two ways of creating data. So one is called create like this, with a pattern, which is nice and quick, but it if you run this twice, it will create data twice, which you probably don't want. Right? There's another way, it's called merge, which is like a getter create or an upsert, and that's what I prefer, at least in the beginnings when people learn Cypher. So I just create a person or merge a person where name equals Michael Hunger, which is my name, and I return this person. Right, so it goes off and creates this node in my database. So of course, I hope you put in your own name, not my name, but if you put in my name, that's also fine. So now I can find this, and I can run this as often as I want. There is only one Michael Hunger ever created in this database, right? So there's no multiple Michaels getting there, which is the difference with if I ran create, then there would be like 1, 2, 3, 4, 5 Michaels, which I don't want. So I can now also find my Michael again. There's Michael. Nice. And now I can connect my personal node to a movie node. So you pick your favorite movie, title, I think Forrest Gump is in there. So we return the movie and the person. Forrest Gump is not in here. Why is Forrest Gump not in here? I thought it was in here. Not so nice. Okay, then I'll pick the matrix. Okay, now it returned my node, my person node, and my movie node that I want to review. And now I can create relationships. And it's basically the same pattern thing, right? So I can find things with patterns, but I can also create things with patterns, as you just saw with the movie node. And now I can actually merge a new relationship called from person, called reviewed, to the movie. And I can give it a variable R and set r.stars equals 5. So I really like the first Matrix movie, so it gets stars. And I could also set a comment as well, and that was slow-mo, for instance, right? Or weapons. I need weapons. But I stick with slow-mo. Right? So, which basically means I find my person, I find my movie, and then I create a relationship between the two. I give it a type. If I leave off the type, that's not allowed. But its merge also means I can run this statement as often as I want. It will not create a second relationship between the two. That's kind of the nice thing about the upsert. If I had create here, then it would create as many relationships as if I run this statement. Right? So, and if I also return the R, then I now suddenly have the reviewed relationship between Michael and the matrix, and reviewed, if you click on this, so this is my name, and here you see stars and the comment as well. So that's a little bit about creating data. So that's what you would use of getting data into the graph. We'll see another example of this with the Stackoverflow dataset in a second. Yeah, so that's for creating data. If you want to have some interactive way of creating data, there's a really cool new thing called, where's my databases? Called Data Importer. So if you say open with Neo4j Data Importer, something I'm really proud of. Let me just clean this out. This allows you to map CSV files to a model. So I can say person and then drag out a relationship here. See, person movie and acted in. And then it says, okay, you don't have data for movie or person or active in, and until you get data for these three, you can't import this. So I would have to add some files, and then I can map attributes. So for instance, I can say, okay, I add properties, I add an ID, and then I can just run the import against my database and then get the data in. I have not prepared this, so I would have to find the right files, which is probably taking a little bit too long. As such, but it's something that is pretty straightforward to do. And in the Graph Academy, in the data import course, it also goes through the data importer as well. Really cool tool. And actually, let me try to find this. Movies.csv. Here is movie data. Okay, we have active in, we have movies and people. There's our CSV data. We open this, and now we can say this movies is much more data here. Here's my people data and my active in data. And now I can basically say for the person, I select the person's file, and I say I want to add my properties from the file. All the stuff I want to add, confirm, and it creates all these properties that you can see here. Because of my weird resolution, it's a little bit weird. And then I select an ID. I think it's this one, the MovieDB ID. And then I click on the movie, select the movies file, say add from file, select it all again, confirm. And movie ID is my ID. And for the last one is the relationship. I select my file, which is acted in. And then I map from person ID to movie ID, and add as last the roles to roll from the file. And now I basically can run this import and import my data. Actually, I don't know how much data is in there. Let's try this. I just need to steal my password over here and put this in. And then I don't want to save this now. Oh, so we need to clean out our data. Let me do this. So if you want to clean out the whole database, you can do match n, detach, delete n, be gone. So now I have an empty database, so it's really empty. So you see no data in here anymore. But if I run import, it was quick. So it took 2 seconds to create 444 people, 93 movies and 372 relationships. And now if I look in my data here again, I get people and acted in relationships with their roles. Right? And this has much more data than our original data set had, including posters. Right. Okay, so that was quick, unplanned data importer demo, which I couldn't resist. Hope you found this useful. And should we take a second to go for questions, Alex, before we go into Stack Overflow?
Yeah, I think that's good. Let's spend a couple of minutes. One question came in from Dan on the data importer. This is fully for new data only. I assume if you have existing data in your database and you want to add to that, that's not going to work with the data importer.
Actually, it works because the data importer is additive, so it doesn't clean out. As you saw, it complained about that there was already data in my database that that it would have duplicated. But it would add to it, right? So you could even add additional. So imagine we ran this movie data input here, and then now we wanted to add, let's say, studios or budgets or so. Then we could also add this to the same graph. And as long as I said before, as long as we have one connection point between the two, like the movie ID or something like that, then I can also add more data to it. So the data import is actually additive and can add more data to the database, which is really nice. Right? I can also run it multiple times. So for instance, I run it once, I can run it again, and it will basically don't break or don't duplicate data. So it also uses merge under the hood. So you can actually take a sneak at the queries. So there's a constraint query that it adds and a load query. And you see that it basically does merge on the ID and then sets the other attributes here, right? Or here for movies, it does the same. So you can also kind of sneak into what it does here in the load summary. So it's pretty powerful.
Yeah, that's very cool. I did not even know that. So that's good. Good to know. Another question, maybe. Let's see what we else have. What is your advice on capture data, change, and updating existing data? Is there a way to best practice kind of method?
Yeah. So there is two directions, right? So you could pick CDC data from another database, like let's say MySQL or Postgres or so, and ingest that into Neo4j. Or you could also look at CDC data from Neo4j itself and send this somewhere else. And there's an Neo4j Common Labs. There's the Kafka connector for Neo4j that can. Sorry. There's my Kafka connector here. Neo4j connector for Apache Kafka, which basically offers CDC integration for Neo4j. And it has different ways of how you can add it to Neo4j. So either you run it in Kafka Connect as an external tool, then it would use polling for CDC changes and can, of course, consume Kafka streams in general. Or you install it as a plugin for Neo4j, then it actually provides proper CDC from Neo4j because it hooks into the transaction management as such, which is unfortunately not available on Aura. But there you can then use the version that goes via Kafka Connect as such. So that's kind of my my recommendation for CDC and change data capture and integration. Yeah.
And then let's maybe do one more question before we go to the finishing 20 minutes. Can we create two nodes in a relationship in just one line? So kind of, maybe you can show that.
Yeah, I can show it actually directly, right? So, so you could do something like that. Like I have person name Alex, and then, for instance, works with person name Michael, right? So this is basically this pattern that I spell out, and either can use create here or merge, and then merge would kind of look for this pattern, and if it doesn't find this pattern, it creates it. Return path. You can even assign the result to a path and return the path. So we would kind of get here Michael and Alex in one go. But I actually don't recommend this. In general, I recommend to split it up into 3 lines where we basically merge one person first, then the second person, and then the relationship. P1 works with P2. So like this. Because then if a partial, if this pattern already exists as a partial pattern, if you put it all on one line, it wouldn't recognize it because it tries to either find the whole pattern, and if it doesn't exist, create it. And if there's a partial pattern, it would not complete the pattern, but it would look for the whole pattern. And because it can't find it, it would create it another time. So that's why you create your person, another person, and then basically the path. Right, and then it would not recreate this as such. So this is what I actually recommend to do, as connecting those like this.
Okay, cool.
And
I think that's what I had for now. Let's go into the final 15 minutes.
Yeah, okay, let's do this. So I clean out the graph again. And what I wanted to show you is Stack Overflow, because you all know and love Stack Overflow, I guess, right? So because it answers all your programming questions. There are also 20,000 questions for Neo4j as well with active members. So if you go to stop users here actually on the tag, that's weird. Here, sorry. So you see also like lots of questions being asked around Neo4j. And if you know Stackoverflow, you know that there's a question with an URL, there are votes, there's text, there are comments, there are tags here, answers, someone posted the question, someone answered the question, or someone posted the answer, there are accepted answers, and all this other stuff, right? And how cool would it be if you can just pull this data really quickly into Neo4j and play around with it? And that's what I want to do for the last few minutes, 10 minutes, and then we go into the closing line. So I cleaned out this database, so with match n, detach, delete n. You don't need to do it. We can also keep it. Doesn't matter. And what I want you to do is to enter :play and then sandbox/Stackoverflow, which is one of our sandboxes and the interactive guide for this one. So it should show something like this. Exploring Stack Overflow, a little bit of prose explaining it. And usually it comes with a predefined dataset, but it also has, this is the model. So we have a user who can have asked a question, can have provided an answer, which answered the question, can have commented a comment on a question, and the question is tagged with text. And what we can do here is, and actually on page 3, there's a statement that can import data from Stack Overflow. As we are running on this Aura free instances, which is a little bit more limited, let me do 2 things, which you also should do, so that it doesn't abort the query. So I just remove Cypher as the tag because most Neo4j questions have Cypher anyway, and I reduce the page size here to 25. You could run it in more circles or in cycles and input more data. There's also more advanced like colon transactions and so on, but I don't want to get down to this. So if you remove Cypher from tags and change page size here to 25 and click run, it actually should in a few seconds fetch the data and add it to the graph. So we get 260 nodes and 377 relationships pretty quickly. And now you see we have something like question, answer, person, question, answer, user, and tag here. Right? And so cool. I hope you all got this to run. And if I look at the statement really quick, what it does is basically it says, give me this tag, give me pages, and then construct an URL here for Stackoverflow API, where the page is the page number here, the tags are in here, and then cite Stackoverflow, and it starts querying them the newest first orders descending. So we can load JSON from a URL, which gives us kind of the JSON response for this. So if I take this URL, it would just let me do this quick. So this is my tag name, Neo4j, and then we had page 1. Then I would get this API response back, right? So a typical JSON document response. And we can use this and construct a graph from it. So the sleep is just for throttling, and then basically we take every question, create a node for the question with merge. As you've seen, we create a person who asked the question, create a relationship between the two, create all the tags for this question, connect the question to those tags. And because we use merge, each tag is only created once, even if it's used multiple times. Then we do the same for answers, create the person who answered, connect the user to the answer and the answer to the question. And the same for comments, and then we're done. Right? So that's basically a still understandable statement which pulls in the whole data model of Stackoverflow, including setting stuff like title and scores and favorites and all this other stuff as well. Right? Okay, that's that. And now we can follow this guide here and look at a bunch of the queries that are in here. So for instance, we can say, give me the labels and of each node and the count of those. Right? So we have 50 questions, 61 users, 63 tags, and so on. So that's just a quick overview. And then we can say, okay, what's the most popular tag in our database? It's very likely Neo4j because we fetched the Neo4j tag. But anyway, if you wanted to change this, you could just change the tag here from Neo4j to JavaScript or React or Go or Kubernetes or whatever you want to look at, right? So that's easily possible. So for us, the top tag is most likely Neo4j, but what are the other tags that are in there? Cypher is also kind of expected, Graph, but then it's already Python, Graph Data Science, and it's, I think we only return the top 5, right? Okay, interesting. Let's continue. So who are the people that ask most questions? So like the people that are really interested in graph stuff. So Dimitri, Stefano, Dan have recently asked more than one question about Neo4j. What's more interesting to me is actually who are the people who are answering questions, right? So this pattern is a little bit more complicated. So this is just user asked question, but here we have a user provided an answer to a question, and then we return the user's display name, how many answers they provided, the average score of the questions, and then we could also add something like how many of them have been accepted and so on. So if I run this, then I see, okay, Jose was super active here. He answered actually 13 different questions in the last 50 questions. So that's pretty high percentage. Tomasz, Rosario, Christoph, and some other folks as well. Right? Okay. So let's copy Jose here as a name because you might need it later. So then the other question is, we want to only see questions with the text cipher and who answered those. So imagine you try to find an expert for a certain topic, right? So you would say, okay, I had pulled in Kubernetes questions, and if I want to have Knative or something like that as a tag, then I would say, okay, I put in Kubernetes question, who answered like most Knative questions, and who could be an expert I ask about something like this. So in Cypher, it would be Rosario answered 2 questions or 50 on Cypher, and then Jose answered 3, but the score here was higher, and it orders by the maximum score. So it's actually by max score descending, and it should probably also order by answers descending, right? So actually, Jose should come first here, right? So if the max score is the same, it should put the higher answers up here. Right? Cool. So that's helpful, right? So because now I know who's the expert within the Neo4j Aura for Ceph questions. If I imported the whole database, the whole 21,000 answers, then I would have this over time. I could add like creation date for queries or who's recent and things like that. Right? So the shortest path you already seen before, and because I only imported a fraction of the data, this doesn't work to here because these two users are not in this data set. I tried this before. But if you could put in other people, then you might find in Rosario B and so let's actually try this. So we have Jose and Rosario B, I think was the other name, right? So nice. So we actually see that they're connected through a comment on a question that are both tagged with Cypher here, right? So that's kind of an interesting, how do I find connections between people as such. Okay, and then what you could also do is kind of say, how does a user engage over time? So of course we don't have so many questions and so much time information here, but if we put in Jose, here we see, okay, in March, he answered one question with Neo4j, but March is also young, right? It's 2nd of March today. But in February, so he actually also had quite some engagement in February, and these are all the tags that he answered on, so which is pretty broad, right? So we have Cypher and caching and Python and Lucene and full text and APOC and so on. So quite a number of broad questions that Rosario answered, which is really cool. Thank you, Rosario. And then we can say which of the questions are not answered, right? So we ignore the ones that have, why does it actually ignore the tags? Oh, we want to see for the non-Neo4j and non-Cypher tags, which questions are not answered, right? Okay, let's do this. Actually, the syntax for this is where not exists this pattern today. So the unanswered questions from the 50 that we imported are like graph, database, epoch. So you could actually pick an area that you're interested in and then go to the questions and answer them as such. So you can, if you think about this, you could already imagine certain areas of the Stackoverflow site that could use that, right? So for instance, active oldest, you can have related tags and similar things to a question here as well, right? And so there's a lot of stuff that you can do just by looking at the queries that we're just running here today. And before we run out of time, this is something that's actually really cool, which is correlation of text, right? So correlation of things in general in a graph, right? So which question, we actually don't care about the question itself, but what we want to see is kind of which tags have been frequently used together. So that helps us to create clusters actually between tags, right? So because our data set is pretty small, there might not be as much insight here, but we could see, for instance, that Python and Neo model go frequently together, right? Because Neo model is in Python object graph mapper or syntax and syntax error. Okay. Or Neptune and Gremlin Python go together, right? So because Neptune supports Python, Neptune supports also Gremlin, so this makes also sense. And so React and Docker, I wouldn't have thought that that's an obvious connection, but as I said, we have only little data in our database. But I could, if I run this on the whole Stackoverflow data set, I see real clusters of, these are all the JavaScript technologies in one cluster. These are all the, let's say, Python technologies in one cluster. This is all data science stuff in one cluster. And so with these correlations, I can actually see quite some cool insights. And then based on these tag correlations, I can actually create new relationships that actually store the count, the frequency of how frequently two tags have been correlated, and then use that for recommendations. So people that answer this tag also answer this tag, and that frequently, for instance. And so I can start doing recommendations based on tag, or I can do related tags, as you can see in the Stackoverflow UI. What are related tags to tag A, right? By just looking at this query, actually, right? which is quite cool. And then you can also visualize this as well. So if I run this, then I get virtual relationships back, which are what I just said is kind of co-occurred and has a frequency of 4. So this relationship doesn't really exist in the database. It just virtually created for the UI. Such. So Stackoverflow is a pretty cool data set. We have quite a lot of content around it as well in general. We even have importing the whole of Stackoverflow in a bunch of minutes. Example, because Stackoverflow publishes their data as dumps, and you can just import the dumps of whole Stackoverflow to Neo4j, and that's a lot of fun. And then you have a really nice data set to work with. Okay, that's just a quick teaser, as I promised, for Stackoverflow. And to close off, what else is there? So I mentioned when answering the question, there are different connectors for Neo4j. There's the BI connector, JDBC connector, the Kafka connector, there's Spark connector for Neo4j. So if you want to integrate Neo4j into other databases or data technologies, a bunch of connectors. I showed you some of the drivers already. These are the official drivers, but there are also drivers for other languages, like, for instance, for Perl or Elixir or Ruby, Rust, and others that are contributed by the community, PHP as well. Graph data science is a really important topic. Where you take the graph not just to build applications, but to get insights, and especially now with machine learning on graphs, there's a lot of really interesting stuff happening in this area. So if you're interested in that, check that out. We have a visualization tool called Bloom, where we have a separate training session next week on 2 weeks. And then other integrations, like a really cool GraphQL integration for Neo4j. We have Spring, people that come from the Java ecosystem. Spring Data Neo4j has been one of my babies. GraphQL as well. New semantics is integration with RDF and data, and pulling data from Wikidata into Neo4j. Alex just ran Meta with Jesus on Tuesday. And they have the Swiss Army knife of utilities for Neo4j as well. So there's lots of other cool stuff that you can use to kind of build out your Neo4j integration. So how can you continue from there? One is, of course, the other session. So next, the Bloom, which is a super powerful node visualization tool for Neo4j. GraphQL session on Martins, and our data science advocate will talk about knowledge graphs and ML languages for doing that. And if you follow this link, it gets you to this page where you can register to the other as well. So please check them out, and I'd love to see you there. Otherwise, I already mentioned Graph Academy, and we have a ton of videos on YouTube as well, both live streams as well as webinars, Graph Connect talks, conference talks, and so on. And actually, we have also our conference coming up. Just need to put in a teaser for that on graphconnect.com, which is in person. I hope we'll make it there. And so it's in June in Austin, Texas, and we can't wait to see perhaps some of you there if you can make it. If not, we'll stream. A number will also be recorded as well, of course. Right. So please join us there, and we'd love to see you if you can make it in Austin. And with that,
perfect.
We are good for the last few questions. If you have any questions left.
Cool. Thank you very much, Michael. And we are about on time to finish, so I don't know if we have much time. Maybe we can squeeze in one more question. Let me quickly see if there's any that we can do quickly. Maybe here's one: MS Code or Visual Studio. Is that something we could use with Neo4j, or would you rather recommend something else?
Yeah, so definitely VS Code can be used with Neo4j. So you can, of course, write your applications there, but there are also enough extensions for syntax highlighting for executing Cypher as well.
Okay. Cool. Well then, thank you for. I think we lost Michael. Well, that's on time. Thank you for watching. Thank you for joining us for the session today, and the great questions and interactivity we had today. I think it was good. Exactly, Stenko. Now it's time for beer. So get your beer. I think that's good. Have a good rest of your day. Take care. Stay safe, and obviously, subscribe to Neo4j. And then you have on YouTube, and then you have your next videos available when they go live. And yeah, maybe I hope to see you soon in one of our next sessions. Until then, take care, everybody. Bye.